Hi, viewers. I'm Linda Reinertz, Integrated Marketing Manager here at Anritsu, and today we're talking to John James, not to be confused with Jesse James, who is his dog. John will be talking to us about PCIe and why it's important in modern bus standards.
Great question. So PCIe stands for Peripheral Component Interconnect Express, and actually it started about 20 years ago. Previous to that, we were using parallel bus standards, and we'll talk more about that in a minute. So the PCIe standard has been around for 20 years, as I said, and it has about 932 member companies that work on the specifications with the PCI SIG. PCI SIG is the special interest group that develops the specifications. PCI Express is it's implemented in high-speed I/O, for instance, on motherboards, components, and it's the interconnection between the chips and also endpoints, such as graphics cards, servers, and things like that. So it is the workhorse of the interconnection in electronics. So, in a nutshell, it's a serial interface.
So, why do we use PCIe?
So PCIe is really a point-to-point connection, which means that you go from, let's say, a microprocessor or PCI switch directly to components on a board or an endpoint. So, for instance, graphics cards, and like a card like this, which is a add-in card, right? The speed is incredibly different than what we used to use in parallel bus architecture, which was a shared bus. Now that created bottlenecks within the transmit system on boards because that was a polling type of a bus architecture. So where PCI Express is point to point, you can transfer and receive at the same time. So it's a lot more robust, lower latency, and less errors than what you would have with a parallel bus standard.
So, John, let's talk a little bit about the technical points of PCIe. What can you tell us about that?
Okay, sure. So part of the PCI is we talked about that it's a point-to-point connection, but better than that, it's a differential pair. So you have two pair running as transmit and two pair running as receive to each component. Now, what that does is it negates what's called crosstalk. And crosstalk is a signal crossover between the lines, and that will impede on the signal and cause errors and lower latency. So with the parallel bus architecture, you couldn't do that, right? And with the speeds the PCI has, the differential pair is actually better for latency and also error detection or error correction. PCIe is also scalable. For instance, the standard calls from anywhere from 1 lane up to 16 lanes. It's also scalable in speed. So if we talk about Gen 1, Gen 1 is at 2.5 gigatransfers per second, all the way up to spec right now that's working on is PCI Gen 7, which is 128 gigatransfers per second. And the real robust part about PCI Express is it's backwards compatible. So if you're designing to a PCI Gen 1 spec, it should work in a PCI Gen 7 system. Okay, that is really important because this is all. If you already have something designed and you're designing for a higher speed, you can actually use that as long as your system was designed according to specification. The speed for PCI Express has been doubling every generation. So for instance, we started at 2.5, went to 5, but we changed not going to 10 because of cost. So really it went to 8 gig transfers, then 16 gig, 32, 64, and now currently with the PCI Gen 7, it's up to 128 gig transfers per second. And if you throw that over 16 lanes, that's a lot of data going through. For power-hungry systems such as graphics cards, server boards, things like machine learning, artificial intelligence, and there's a host of other things that PCI Express can handle. So in a nutshell, it's really the speed, the scalability, and the robustness of a PCI system.
What is in the background there? What are you showing us? What is that instrument?
Oh yeah, this is a compliance board. It's an example of an adding card. So you see the fingers here, and you've probably seen this in your computer. This is a by 16 interface here. But turn it over, this is a by 1. You can actually plug this into a motherboard, for instance, a PCI, and they would both work. The system would recognize how many lanes you're using, right? So here you got 16 and 1, and the system automatically recognizes that and will use the lanes to transmit that data. So, and we have different size cards. For instance, I have what's called a baseboard here, and this kind of looks like your motherboard. So the PCI adding card would sit right here. Now, if you're using, let's say, a base system, I don't have one here, but it would have components on here. Say, for instance, your microprocessor and other chips here. Well, that PCI Express, those lanes are tied together, right? And you can have multiple, so I talked about, multiple lanes going to different components and communicating at the same time, transmit and receive. So, yeah, so this is pretty much what we use in the field and what customers design too.
And what's behind you back there? That the TV looking thing.
Oh, so yeah,
Since I'm not technical, I don't know what that
okay.
is.
So this is Anritsu's MP1900A BERT. That's a bit error rate tester. This is our flagship bit error rate tester for testing other than PCI Express, USB, Ethernet, all the technologies, all the high-speed technologies that are in the technology in the world right now for testing purposes. So, yeah.
I just figured out what the E stands for. It stands for Express, right?
Express, it does. And as a matter of fact,
Yay!
good point. So PCI actually started about 32 years ago. And PCI was it's a parallel bus. There were other parallel buses such as ISA that worked with the older computers and things like that. And it was a parallel system. And what the PCI SIG came up with, it was just too complex to lay out parallel signals on a board. So we came up with a serial I/O, a serial interconnect, right? And so that's what the Express stands for. As we talked about, it's more robust. You have a lot more lanes, a lot more data, and it's simultaneously transmitting and receiving at the same time, where a parallel bus cannot do that. You have to arbitrate the data across the parallel bus.
Awesome. Thanks, John. I really appreciate you taking us through that. That was a lot of good information. So keep an eye out on our social media channels for any new and upcoming episodes. We look forward to seeing you again.